My name is Nick Barton and I live near Oslo in Norway. And I guess for 50 years I've been a rock mechanics and tunneling engineer, mostly working outside Norway in the last 20 years, as a private consultant. But I was 30 years in a research institute called NGI, Norwegian Geotechnical Institute. But since 2000, I've had my own one-man consultancy and traveling to many countries, seeing problems and writing reports, and then traveling to another project. So many travels each year. We're going to talk about tunnels, of course, but tunnels specifically in jointed rock, and try to emphasize the differences that this reality is from the numerical models that you see so much of now. The young people, they're using so many numerical models. They're very colorful, but they're approximations of the reality. So we want to get back to the basics and show what's really happening around a tunnel, and emphasize the difference between the most common tunneling actually is drill and blast, of course, with sprayed concrete and rock bolts. We call it single shell. That's the most common in the world in mining and in civil engineering, hydropower, and so on. I know in Brazil, most of the tunnel would be for railways, metros, and roads. And there they use, you could say, a competing method, which we call double shell. It's NATM, New Austrian Tunneling Method. It's actually 50, 60 years old. The one we will be talking about is 30, 40, 50 years old. We call it NMT, Norwegian Method of Tunneling. And we rely a little bit more on the rock, maybe, than the NATM method. We try to reinforce the rock. We don't rely on the what's called lattice girders that is used in NATM, because there have been some important tragic collapses actually in Brazil and other places when using these lattice girders. So the first stage of the NATM, when you just have single shell, the shotcrete, the bolts, the lattice girder, is actually very critical. And because this is the final stage for single shell, where we use sprayed concrete and rock bolts, I think maybe we have better methods for estimating the stability, because we have to rely on that stability, right? We're not going to come with a final concrete lining like you see in most tunnels in Brazil. So we'll also be emphasizing how you can improve a rock mass with pre-grouting, drilling holes, drilling like an umbrella of holes ahead of the tunnel, and injecting very fine-grained cements at high pressure, and actually improving the quality of the rock mass. A little bit like you do at dam sites, where there's maybe millions of kilometers of grout holes helping to lengthen the drainage path under dams, right, to make dams more stable. So we'll draw some parallels between dams and tunnels also when we're talking about the grouting. So there'll be many different things. Also, what about when we use tunnels to transfer water in a hydropower project or for a water supply, or when they're building a dam, they need to divert the river, right? And some people use very high velocities through these tunnels, and sometimes that causes problems, because the method that I developed like 40 years ago, called the Q system, it was not based on very fast water velocities. So we have to be aware of that and have thicker linings, maybe concrete lining, concrete floor, if we're going to divert water at high velocities. Because the lighter support that we use to make a tunnel safe may not survive very high velocities of water, like 10 meters a second, for example. That's almost the maximum speed anybody could sprint. The very best runners, they run at that speed, and if water's going through a tunnel at that speed, it can erode the floor of the tunnel. It can damage the shotcrete and things like that. So you have to have special design if you're going to have very high velocities. So we will point out problems like that because there have been some dramatic failures with very high velocities. So actually, part of this article will be about pre-injection in jointed rock masses to improve the quality of the rock mass. And by chance or by design, I'm not sure, some of the work that Eda did actually before we met each other, she did it while she was working in IPT, the Research Institute in Sao Paulo. And at dam sites, they used to measure the permeability using several boreholes simultaneously. And she found out that the permeability of the rock mass was kind of anisotropic. It was different in different directions. Could be even 100 or 200 times more permeable in one direction because of the jointing than in another direction. And in one of these studies, it was very interesting. They did that measurement, and then the contractors grouted the holes. And then in the same location, new holes were drilled through the grouted rock, and Eda's team measured the permeability once more, and these maximum directions of permeability, they'd all rotated and reduced in magnitude. And just by chance, the Q system that I developed has parameters like the number of joint sets and the properties of the joints that is exactly suitable for modifying as a result of the grouting. Yeah, so we know from her work that some of the joint sets are grouted. That's the reason for the rotation of the permeability. So I can evaluate that using the Q parameters, and we can relate that to improved things like seismic velocity that is measured at dam sites before and after grouting, and also deformability, very important at dam sites also. So some nice correlations between tunneling behavior and the desired behavior at dam sites. So that'll be part of our article as well. Yeah, I mean, that will be so nice. That it's been a long time without travel and without conferences for everybody, yeah. So hopefully we will all be vaccinated many months before this before this event. So it'll be safe and allowed to have actual physical conferences. Lots of colleagues in Latin America, and it'll be nice to see them again and